The global electric vehicle market demand is expected to reach an overwhelming estimation of over $1,200 billion by 2027, which is massive. For now, the electric vehicle industry is in a rising situation, and they are rising at a tremendous speed. The thing that can push this growth more than any other factor is the innovation of a new, much efficient battery. Tesla is currently using lithium-ion batteries, and they are trying to make them better. But there are some more promising battery technologies, the solid-state battery being one of them. How effective are solid-state batteries versus Tesla's current ones, including their future 4680 batteries? In this video, we'll be covering the leading companies working on solid-state technology, and then we'll see how they fare against Tesla in terms of energy density, charging speed, battery life, and more. But first things first, what is a solid-state battery? Most current lithium-ion batteries have a liquid electrolyte with lithium salts, but solid-state batteries include solid electrolytes. Now, the biggest advantage of this solid electrolyte is liquid electrolytes have safety and health issues, as they use flammable and corrosive liquids, but being solid, the solid-state batteries don't pose that threat. There are some facts about the solid-state batteries, and to know that, try watching this video link on the top of your screen where we have discussed this battery's mechanism. Moreover, solid-state batteries can store considerably more energy by weight and volume than today's lithium cells. Especially the QuantumScape lithium metal solid-state battery promises a battery technology that enables electric vehicles with a driving range comparable to combustion engine-based vehicles. Its solid-state batteries have very low self-discharge rates, allowing multi-year power storage with minimal loss, guaranteeing a long lifetime. Now, those are some very promising characteristics that can literally change the future of EVs. Companies working in solid-state battery. According to the present technology, anyone who could develop a cost-effective and efficient solid-state battery would rule the EV world. Developing a practical solid-state battery has generated considerable interest from automotive companies, and several of them are in a competition to develop a perfect battery, which will just skyrocket their position in the future automobile industry. QuantumScape. QuantumScape Corp is a battery startup that counts Volkswagen AG as its largest shareholder, with another tech titan, Bill Gates, as their investor, and its board member includes ex-Tesla executive J.B. Straubel. Pretty heavy portfolio, right? Well, QuantumScape currently seems to be the closest to actually building better batteries. QuantumScape has announced stunning performance figures via a video call at the end of 2020. There were some difficulties in producing a solid-state battery, and QuantumScape says it's cracked the problem with a new design using lithium metal anodes. According to QuantumScape's data, their battery can give up to 80% longer range compared to today's lithium-ion batteries. Its cell can charge to 80% of capacity in 15 minutes and can retain more than 80% of its capacity after 800 charging cycles. Whoa, those are a lot of 8s. It has nearly double the energy density of top-shelf commercial lithium-ion cells. Toyota. Toyota has been tepid in its attempts to launch electric vehicles to compete with the increasingly large number of highly competent EVs already out. Although many doubted this Japanese automobile giant's strategy, they had a plan all along. Toyota was actually developing a solid-state battery. Toyota, in partnership with Panasonic, currently has more than 1,000 patents covering solid-state batteries. They're focusing on a sulfur-based electrolyte that is said to allow for a more efficient ion transfer between the electrodes. The batteries are set to be a total game-changer for EVs, since they charge quicker and offer more range in the same size package. Toyota says that its new SUV will be fully charged from flat in 10 minutes, and that this will grant a range of 500 kilometers. The still unnamed SUV is expected to debut in 2021 in limited quantity. Samsung. Looks like Samsung also wants a piece of this solid-state battery technology. Samsung this year presented a study on high-performance, long-lasting, all-solid-state batteries. Instead of lithium metal anodes, Samsung decided to use a thin silver carbon layer, and according to researchers, this yields a battery with a higher capacity, lengthens the cycle life, and makes the battery safer. At 50% smaller by volume than a typical lithium-ion battery, Samsung's prototype could enable 500-mile electric car ranges and cycle lives over 1,000 charges in a much safer package. For now, it's just a prototype, and Samsung isn't discussing when we can expect to see it become a commercial product. Well, these surely are some promising projects giving us bright hope of a breakthrough in the EV sector. Now to Tesla's newest battery technology, the 4680 battery. Recently, Tesla unveiled plans to develop a tabless battery that could improve an electric car's range and power. These new tabless cells, which Tesla is calling 4860 cells, will give the company's EV batteries 5 times more energy capacity, make them 6 times more powerful, and enable a 16% range increase for Tesla's vehicles. Tesla also said the new batteries would be 56% less expensive to manufacture and are being developed entirely in-house. Now to the comparison of Tesla's lithium-ion batteries versus the future solid-state batteries. Energy density. Tesla. The energy density of current 2170 batteries used in Tesla's Model 3 is around 260 watt-hour per kilogram, and Tesla CEO Elon Musk has hinted at a 50% more energy density in 3 to 4 years. Solid-state battery. The QuantumScape prototype shows it offers somewhere between 380 to 500 watt-hours per kilogram, but they plan to establish the first production line in 2025 at best, while Elon says the lithium-ion ones could achieve the same 1 or 2 years earlier. Charging speed. Tesla. With the Tesla superchargers, you can expect an 80% charge for the 2170 batteries in approximately 30 to 40 minutes. For 4680, to charge from 10% to 80%, it would take around 25 minutes. Solid-state battery. According to QuantumScape data, it would have the capability to charge to 80% capacity in 15 minutes. QuantumScape's ceramic separators work at high rates of power, which allows it to give the battery that capacity. And Toyota says their batteries can be fully charged in 10 minutes. Price. Tesla. According to researchers, Tesla's 2170 battery packs cost $156 per kilowatt hour, which would put the cost of a 90 kilowatt hour pack at around $14,000. But according to Elon Musk, the 4680 batteries would be half as expensive as the company's current cells. Solid-state battery. A general battery's cost is around $220 per kilowatt hour currently, but the QuantumScape and some other development can drastically reduce the price because these batteries require less cooling during the manufacturing process, which can make it cheaper to produce. Safety. Tesla. Tesla uses lithium-ion batteries, which have liquid electrolytes, and these are flammable, and any leakage of these would lead to safety concerns of batteries and overall vehicles. Solid-state battery. QuantumScape's solid-state separator is non-combustible and isolates the anode from the cathode even at very high temperatures. Battery life. Tesla. According to a private study, the researchers found that the battery of a Tesla should have no issue reaching the 500,000-mile mark. And Elon has promised that Tesla would soon be able to power its electric cars for more than 1 million miles throughout their lifespan. Solid-state battery. The QuantumScape's one is claimed to be designed to last for hundreds of thousands of miles of driving. Now, for the availability, don't just expect them to be out in 2 or 3 years. QuantumScape declared that it will have a production-ready solid-state battery by 2025. Toyota plans to have solid-state battery technology in its production vehicles by 2025. And Samsung's researchers and engineers are focused on continuing to develop and refine solid-state battery materials and manufacturing to first use them in electric vehicles. But this isn't the only battery technology that could have a big impact on the future. There are more. Want to know what they are? Tap on the video at the top of your screen.